In this session, we are going to discuss the natural deduction of predicate logic. So we already have discussed what is natural deduction in terms of proportional logic, and what all we have seen. You have an insertion, introduction, elimination, or introduction, elimination, implies introduction, elimination, negation, introduction, elimination, double negation, elimination, and these things actually comes under your natural deduction rule. And along with your double negation insertion, modus tollens, law of excluded middle portion, and proof by contradiction method. So all these rules we have discussed in terms of your proportional logic. And what does this predicate logic actually means? Some statements of your proportional logic along with your universal quantifier. So along with all these connectors, we'll be having universal quantifiers to quantify your statements. So that is your predicate logic. So what are the quantifiers we have seen? For all x, there exists an x, and we also noted this equality conditions. Okay, so the natural deduction in predicate or logic, along with all these rules, we are going to have 6 more extra rules. For all x insertion elimination, there exists x insertion elimination, and equality insertion and elimination. So this video I'll just show you the rules alone, and in the next video I'll take some examples and I'll show you how it is actually working. Okay, so first step is equality condition. So equality, to insert an equality between two terms, we can directly insert it. When I have term t, I can directly say that t1 equal to t. Sorry, t equal to t, or t1 equal to t1, t2 equal to t2, whatever it is. Okay, when there is a term, that term is equal to another term. So it is your equality insertion. And when you want to eliminate your equality, rule for eliminating equality, two terms are given. T1 equal to T2 is given. It is already equal. And there is a formula. There is a predicate logic formula in which T1 is substituted, substituted instead of X. So in that case, we can eliminate this equality condition and we can write it as this proportional logic formula. Instead of T1, we can substitute T2. So that is your equality elimination condition. Okay. So this is how an equality can be inserted between a term, and this is how an equality can be eliminated from a term. And similarly, for your for all, the case for all x, when you want to insert for all x, when you want to eliminate for all x. So elimination is easy. I'll write the rule for elimination first. So when you have a predicate logic formula given with for all x binding, it means that it satisfies for all term. So we can directly eliminate this for all x, and you can write it as with the term t substituted for this x. Okay, this predicate logic formula is composed of a universal quantifier x, and for all the substitution of x, your formula works well. So there is a term t, and for surely the term t will works good. So we can eliminate this for all x, and I can rewrite the formula with the substitution as t instead of x. Okay, so this is your for all x elimination. And similarly, when you want to insert, so this insertion of for all x, when you want to introduce your for all x, this is a bit complicated one. So how does it actually works now? We start with the term x naught, some term, and if you are able to derive to the formula of pi of x naught replaced in place of x, you can write it like in that case, start with x naught. If you are deriving to the formula with the substitution of x naught instead of x, you can write it as for all x of y. Okay, so this is your for all x insertion. A bit complicated. I'll show you a few examples later in the videos for understanding this rule. Okay, now what is the left out one? Left out one is there exists rule. So there exists rule actually works like this. There exists x of, when you want to insert, when you want to introduce this, there exists x. When you have a formula and a term t actually satisfies this formula, as t can be introduced in terms of x. So what is the meaning of there exists? At least for one case, it is satisfying. So here for this t as a x, it is satisfying. The formula is satisfying. So in that case, we can directly introduce your for all x pi. This is your introduction. And elimination is a bit difficult. It works similar to that of your for all introduction. Okay, so when you want to there eliminate there exists x, we have to start with some x naught and a formula pi, a predicate logic statement pi of x naught in terms of x and derive to a term, then we can say that this term is valid. Okay, so you'll understand it better when you see some examples over here. So along with all the 14 rules, I think 14 rules of your natural deduction and derived rules of your predicate logic, these 6 rules of proportional logic, these 6 rules of predicate logic will be merged together. And this is your overall package for natural deduction in your first order logic. Thank you.